Page two, page two. I was going to try to rap like, I'll do it for you, but I won't. All right, if we launch a cannonball, what angle gives its furthest range? 45 degrees. Just memorize that, please. All right, now we have a target T like this for number 7. And the building's 10 meters tall. We want to know the horizontal speed at which the ball leaves the roof. So one thing I want to say is when you see a problem like this, where we launch horizontally, please remember V naught y is 0 to start with. So let's go ahead. Let's ignore the problem. Let's solve for the time. So I know that y naught is 10. I know that y is 0. I know the time is unknown. I know that I have an acceleration of g as negative 9.81 meters per second squared. This would be meters. I know that x final is 10. And I know that x is 0. And sorry, x 5 in this case. So let's go ahead and get the time. So I'll use y equals 1/2 gt squared plus v naught yt plus y naught. And so I will end up getting that 0 equals 1/2 times negative 9.8 times t squared plus 10. When we solve for t, I'm going to end up getting about 1.43 seconds. Now let me go ahead and take a proper look at what problem 7 asks us. They want to know the horizontal speed with which the ball leaves the roof to strike the target. So I'm going to use x equals v naught xt plus x naught, or 5 equals v naught x times 1.43 plus 0. When I go ahead and simplify that, I'm going to actually end up getting 3.5 meters per second. Let me just double check that. Indeed. All right, moving on to problem number 8. It says an object slides off a roof 10 meters above the ground with an initial speed of 25 meters per second is shown. The time between the objects leaving the roof and hitting the ground is most nearly. Well, what's really funny is we get a 2-for-1 deal here. It turns out the launching speed has absolutely nothing to do with the time it takes to hit the ground if the height's the same. So we actually can borrow the answer from here and circle 1.43 meters per second. So that's the second page of exam 3.